Hello everyone, I hope you are all in good condition and healthy. Welcome to Meet Me Party Roseate on Pero's Cement Techno channel. In this session I will explain about cement milling technology. The development of cement grinding process technology, especially to produce cement with large capacity, with low electrical energy consumption, and low maintenance costs. Several companies develop different types of cement milling technology, and of course each has its own advantages and disadvantages. Several types of cement grinding process equipment, including ball mill or tube mill, vertical roller mill, roller press or HPGR, and horomill or horizontal roller mill. In this video material, we will only explain in outline, and in the next video material, we will discuss one by one the types of cement milling equipment in detail. We recommend that you watch this video to the end, so that you can understand the functions and working principles of each type of cement milling equipment. Before we continue this discussion, for those of you who have not subscribed, please subscribe first, like and comment, so you can take advantage of this video material. Milling theory. The definition of milling or comminution is, 1. Process for reducing material size. 2. The process of breaking materials into smaller or finer particles. Correlation between material size reduction and energy input is, the energy input is proportional to the resulting particle size reduction. Or the finer the particle size, the higher the energy consumption used and vice versa. This is an example of traditional comminution in 16th to 17th centuries. The crushing of cement materials is done manually, using hammer by human power. And the crushing of cement materials is done by pounding, or pressing it using simple equipment. Edge runner in 18th century. Milling cement materials are ground using two rollers, which are roller rotated by donkeys running around the table. And another picture is milling cement materials are ground using one roller, which are rotated by donkeys running around the table. The evolution of comminution technology. In the past few centuries, to refine the material still using simple manuals and equipment. From this mechanism, experts design and manufacture material milling machines on the basis of impact, friction and compression. In 1890, experts made a machine for the material milling process, which used a rotating steel tube, and inside it was filled with a steel ball as the grinding medium, and later called the ball mill. Then, in 1930, began to develop a material milling machine, with the basic elements of compression and friction, namely using a table and a rotating roller, and later called the vertical roller mill. Furthermore, in 1980, another material milling machine was developed with the basic element of compression, which uses two rollers that rotate in opposite directions, and is called a roller press or high-pressure grinding roller. Then, in 1994, introduced a material milling machine in the form of a rotating steel tube. And inside there is a roller as the grinding medium, and later called horomill or horizontal roller mill. For the next, what kind of milling machine will be made and developed? This is an example of a ball mill design for cement grinding. Ball mill is a steel tube with a length of 3 to 4 multiplied the diameter, the inner walls of which are lined with steel liners, and filled with steel balls of various sizes. In general, the ball mill is divided into two chambers which are bounded by a diaphragm. The first chamber is used to crush large materials, then the second chamber is used to grind the material from the first chamber. The ball mill is equipped with trunnion bearings at the inlet and outlet of the mill, so that the ball mill can be rotated using a driving motor smoothly. The material is fed through the inlet hole, and the material after going through the grinding process comes out through the outlet hole. The material that is ground in the ball mill can come out, due to the pull of air from the mill ID fan. This is a picture of a ball mill element. Compartment 1 is filled with large steel balls for coarse milling. Compartment 2 is filled with smaller steel balls for fine grinding. Intermediate diaphragm for barrier, so that large steel balls do not mix with small steel balls. Outlet mill diaphragm and material discharge, serves to prevent the steel ball from coming out of the mill, and to drain fine material through the diaphragm hole slot. Arrangement of material feed into the mill, through the inlet hole. Fresh air inlet to adjust the volume of air into the mill, using a damper. Air outlet, which is connected to the mill ID fan, to draw air and fine material out of the mill. Grinding media in ball mill. For ball mill without pre-grinder, chamber 1 steel ball size is 50 to 90 mm in diameter, while chamber 2 is 17 to 40 mm in diameter. For ball mills using pre-grinder, chamber 1 steel ball size is 30 to 40 mm in diameter, while chamber 2 is 17 to 25 mm in diameter. The standard level of grinding media between chamber 1 and chamber 2 is the same between 29 to 34%. Ball mill cement mill in operation. This is an example of a ball mill, with a cement production capacity of 200 tons per hour. Ball mill diameter, 4.5 meters and 13.5 meters in length. Ball mill rotation speed, 13.8 rpm. With drive motor power, 4,500 kilowatts. Vertical roller mill. Vertical roller mill consists of grinding table and rotating roller. Its function is to grind the material. Table drive motor, its function is to rotate the table. Hydraulic system, its function is to control the roller pressure. Separator, its function is to control the fineness of the product. Feed inlet, its function is to enter the feed material into the mill. Table and roller vertical roller mill for cement grinding. In general, there are those that use 3 rollers, 4 rollers and 6 rollers. This depends on the production capacity and design of several different grinding equipment manufacturers. The gap between the table and the roller is set the same, but over time there will be a slight difference, because the wear rate of the roller is not the same. To adjust the roller pressure against the material on the table, use a hydraulic cylinder. Milling process on vertical roller mill. Grinding force is roller weight plus hydraulic pressure. The table is rotated using a motor drive. Feed material of various sizes is loaded onto the rotary table, and after the material touches the roller rotates, and the grinding process occurs. The maximum material feed size is 5 to 8% of the roller diameter. For more details, we can see in the following video. This example vertical roller mill. The FLSmith OK mill uses pressure and shear, generated between the rollers and the rotating table to crush clinker and additives. Feed material is directed onto the grinding table by the feed chute. The mill is prepared for high pressure grinding, up to 1040 kN per square meter. The rotation of the grinding table accelerates the material towards the grinding track and passes it under the roller. The inner part of the patented grooved roller profile evens out and consolidates the material before continues to the next roller. The outer part creates highly concentrated grinding pressure, allowing air to escape through the middle ground. Partially ground material passed into the hot gas stream, which also provides drying capability, and moisture in the materials evaporates almost immediately. The separator allows material that has reached the required fineness to leave the mill, while it rejects oversized material and sends it back to the table for further grinding. Process gases enter the mill through the inlet ducts, and fresh feed enters the mill through a rotary air solution. Final product is collected in bag filter. Total time for material to pass through the mill to collection in the bag filter is less than 2 minutes. High-pressure grinding rolls. Consists of 2 rollers, one static roller and a moving roller, meaning that it can be adjusted. Both rollers rotate at the same speed, rotating in opposite directions. There are several types of roller press, depending on the manufacturer and production capacity. The high-pressure grinding roller was applied in 1984, and the average production can reach more than 200 tons per hour. Efficiency, 1.8 to 3.5 higher than ball mill, and 1.1 to 1.4 higher than vertical roller mill. This example HPGR Pro. We've responded to customers' growing demands by developing the ThyssenKrupp HPGR Pro, for even better performance and much lower production cost. It meets the higher demands for economic efficiency and reliability, its entire life cycle. The HGPR Pro feature innovative technology and digitalized functions. The rotating side plate at the roller ends and the improved material feed enable up to 20% more throughput than conventional HPGR, while cutting energy consumption by around 15% and increasing roller lifetime by up to 30%. Where protection segments protect the side plate, and can be adjusted or replaced without removing the rollers, which save time. The unique controlled mechanical skew limiter used a mechanical locking device to limit the movable roller's skew. The roller can thus adjust to different feed condition, resulting in safer operation, fewer outages and downtimes. Application of hydraulic roller crusher or high-pressure grinding roller for cement plant. Roller press pre-grinding combination with ball mill. The feed material is fed into the hopper through the bucket elevator. Then, the material is fed into a roller press which is adjusted using a proportioning damper. The coarse material from the roller press returns to the roller press, and the fine material is fed into the ball mill for a finer grind. The material from inside the mill is fed to the separator through the bucket elevator, and some enters the filter bag house into product. The material in the separator is separated between fine and coarse. The coarse goes into the mill and the fine goes into the filter bag house into products. Working principle of high-pressure grinding roller for cement grinding. Roller press finish grinding with 2 levels of separator. The feed material is fed to the hopper through the bucket elevator, then the material is fed to the roller press for the grinding process. The material from the roller press is fed to the bottom separator, the coarse material is returned to the roller press through the bucket elevator. The material from the lower separator is separated again in the upper separator, which is coarsely returned to the roller press. Then the fine material enters the cyclone and baghouse filter into products. The last one is Horomill or horizontal roller mill. Horomill is a type of cement grinding equipment consisting of a large but short steel tube, and the steel on the inner wall is lined with a steel liner. As a grinding medium is a roller, and to control the pressure of the roller using hydraulics. For more details on the working principle of Horomill, we can see in the following video. Horizontal roller mill, Horomill registered. Horomill advantages, including, for milling raw materials, 50% energy consumption compared to ball mill. And for cement grinding, maximum cement fineness 4,000 square centimeters per gram. 70% energy consumption compared to ball mill. Then for the slag milling, maximum cement fineness 4,800 square centimeters per gram. 60% energy consumption compared to ball mill. Comparison of different grinding systems for cement. To produce cement with a blane fineness of 350 square meters per kilogram, the energy used is, for tube mill or ball mill equipment, the energy used is between 35 and 38 kilowatt hours per ton of cement. Then, the type of equipment is vertical roller mill, the energy used is between 27 to 30 kilowatt hours per ton of cement. Then, type of roller press equipment, the energy used is between 22 and 26 kilowatt hours per ton of cement. And for the horizontal roller mill equipment, the energy used is between 24 to 27 kilowatt hours per ton of cement. That was the description of cement milling technology. We will end it here, and in the next video we will discuss in more detail each type of cement milling equipment. Thank you for watching this video, hopefully it's useful, and don't forget to subscribe, like and comment, and share it with your friends who need it. See you in the next video.